So, distinguished colleagues, it's 2 p.m. sharp. Once again, good afternoon, distinguished colleagues and guests. It's September 15th, 2021, 2 p.m. Moscow time. We're beginning the panel session for the defense of the thesis by Anastasiia Vediakova. A thesis is submitted for the academic degree of the candidate of Sciences in Physics and Mathematics. Their specialization is 231, System Analysis, Control and Information Processing. Previously, the specialization code was 051301, also System Analysis, Control and Information Processing. Physics and Mathematics. The topic of the thesis is real-time estimation methods of parameters for harmonic signals with delay introduction. That's the title of the thesis. So, any objections? No? Okay. Under the order issued by the Academic Secretary of St. Petersburg State University as of June 4th, 2021, number 6082/1, I, Nikolai Yegorov, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Electromechanical and Computer Systems Modeling of St. Petersburg State University, was appointed the chairperson of this dissertation board. The order also approved the candidacies of the members of our board, and let me introduce them. Alexei Zhabko, Doctor of Sciences in Physics and Mathematics, Professor, Head of the Department of Control Theory of St. Petersburg State University, so he's here with us. Thank you, Alexei. Nikolai Kuznetsov, Doctor of Sciences in Physics and Mathematics, Professor, Head of the Department of Applied Cybernetics of St. Petersburg State University. Yes? Thank you, Nikolai. Oleg Stepanov, Doctor of Technical Sciences, Professor, corresponding member of the Russian Academy of Sciences, Head of Scientific Educational Center of the Elektropribor Central Research Institute. Thank you, Oleg. And Denis Yefimov, Doctor of Technical Sciences, Professor of the National Institute for Research in Digital Science and Technology, INRIA, France, is working remotely. So, Denis, do you hear and see us? Yes, okay, thank you. And Anastasiia Vediakova is our candidate for the degree today. Usually we also have the thesis supervisor with us, but Professor of our university, Doctor of Sciences in Physics and Mathematics, Evgeny Igorovich Veremey, was the thesis supervisor, but unfortunately he is no longer with us. He passed away, and we can say a lot about him, but I would like to commemorate his memory with a moment of silence. Thank you, colleagues. I would like to inform you that the panel session of the dissertation board is being recorded and broadcast on the St. Petersburg State University website, and our speeches are also interpreted from Russian into English and vice versa. Currently, we have an email address posted on the page with live broadcast of the board session, and all the listeners can voice their opinions or submit their questions to Ms. Vediakova online. The questions regarding the thesis or scientific discussion. These questions will be forwarded to me by our technical service, and I will read them out during the discussion. The questions must be related to the speech of the candidate for the degree and to the content of the thesis, and you should also state your name and position if you submit a question. The questions that have nothing to do with the scientific discussion and this thesis estimate will not be voiced. Now a few words about the specialization code. As I've already mentioned, the code remained. The passport, however, or rather it's vice versa, the code was changed, and the passport, system analysis, control and information processing remained as it was. Yes, I've read it out carefully because being the member of the expert board on information processing and control, I was one of the authors of this passport and passport for 0513-18. And as the passport remained unchanged, we still can use it. And it's clear that Anastasiia was also based on this passport when she wrote her thesis. And as this change happened, in order to execute the order of the Ministry of Science and Higher Education, as of February 24, 2021, number 118, we've made an amendment, and the specialization code for Anastasiia was changed. And so changes were introduced in the order on the approval of the Dissertation board, and our board was approved for the defense of the thesis by Anastasiia Vediakova in specialization 231, system analysis, control and information processing. That's the order of St. Petersburg State University as of August 19, 2021. So, dear colleagues, any comments about that? About the information that I voiced? Maybe someone is interested in some specific points. I have a question. You said that passport was unchanged, so that's the project of the passport that was unchanged, because the approval is something that awaits us. Well, Oleg, yes, you're right. I was not quite accurate. That's the project of passport, but still I called my colleagues who are still in this export board, and they said that they considered the draft carefully, and no amendments were introduced by the technical experts, and usually they look through this information. Yes, but today it's the last day when you can submit a proposal on the introduction of to the specialization code, but why I'm saying that is that I'm not sure what about physics and mathematics, but in our passport, system analysis, control and information processing, technical sciences, we made a proposal according to this topic, because the observers and filters issues that are actively used in control theory, they were just dropped out. Okay, Oleg, if you write me a note, I'll call my colleagues and the chairman of the expert board, and I'll learn what do they think about your offer. Though I asked to preserve the previous passport. Okay. Yes, you know, every amendment can have certain consequences, but that's not the case. I'll learn about that for sure. Let's continue. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local normative acts, the session of the Dissertation Board is valid providing 2/3 of the appointed board members are present. And the total number is not to be fewer than 4 people, and our Dissertation Board consists of 5 people. Everyone is with us today, including 1 member of the board who is working remotely. And we have a multimedia connection with all the members of the board, as well as with our candidate for the degree. Therefore, we have a quorum. and we can finally start. Well, a few words about our agenda. First of all, we'll listen to the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. The chairman's replies to questions, if any. So 5 minutes for that. Then the second point. The candidate's presentation providing an overview and findings of the research. 20 minutes for that. Then questions to the candidate regarding the presentation, no more than 2 minutes per question. Then the candidate will reply to the questions, and we can ask the candidate if she's comfortable to answer all the questions at once or answer them step by step after each review. We'll sort it out a bit later. Then we'll listen to the reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions. Ten minutes per speaker. Then the chairman is the last to read his review on the thesis. So I'll read my report, and then the candidate will comment about the reports on the thesis and will reply to the questions, either to all the questions at once, or maybe it will be more comfortable to answer them after every report. Then we're going to have an open discussion as usual. Anyone present at the defense may state their positions or ask questions on the thesis. 2 minutes per question. And I kindly ask you to fill in the registration form and introduce yourself before you have the floor. Here I'm talking about some external people who are willing to take the floor. And we also have here the people who are not the members of our board, and they can ask their questions during the open discussion. Or maybe they can characterize the work if they wish. But still, you should apply if you want to take the floor. Then, the chairman will ask the questions submitted during our broadcast via our website. Then the candidates replies to the questions. Then we could have listened to the candidate's thesis supervisor, but unfortunately not today. Then we're going to have a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree, and the discussion of the results of the defense is not broadcast. And only the members of the board stay during this discussion. Therefore, before the open balloting, I may ask everyone, except for the members of the board, to leave the room. Then we're going to make a decision on whether to confer the academic degree or not. And finally, we're going to listen to the candidate's closing speech. Any questions or comments on our agenda, dear colleagues? No. Okay, thank you. Distinguished colleagues, as there are no questions or objections, I believe we can give the floor to Anastasiia Vediakova for her short report on the thesis. I did not list all the documents that we have, but I would still like to mention that all the documents comply with the requirements, and the dissertation support department has all the copies. So, Anastasiia, please, you have the floor. Thank you so much. Distinguished members of the board, distinguished colleagues, distinguished guests, hello. I would like to make you acquainted with the major results that we obtained during my thesis. Anastasiia, a bit louder and closer to the microphone, please, because these are not just the members of the board who are listening to you, but also other people. So, do you hear me well? Yes, Denise? Okay, thank you. So the thesis is dedicated to the identification of parameters of harmonic signals in online regime. So we provide estimates for the current values of signal parameters. And regardless of the fact that this study is quite a long one and there are a lot of results, still up until now this topic is quite relevant and it arises interest in many researchers. Maybe due to the fact that there is no unified and simple approach to solution. And still the solution of this problem is quite in demand in many fields of science and technology, and just as an example, we can resolve the problems of compensation of external perturbations, or maybe diagnosis in different systems. And third chapter of the thesis is dedicated to the possible applications of the developed approaches to some applied problems. And the first problem was the assessment of the angular rotation speed of the PMSM rotor, and we also assessed frequencies and introduction of it to the contour of a reverse connection. And the goal here is to provide estimates of harmonic signals in online regime that guarantee convergence, global convergence to zero. And in order to achieve this goal, we decided to resolve the following problems. We assess the parameters of polyharmonic signal with permanent parameters. And also we assess frequencies of harmonic signal with changed parameters in time. And we also considered, we also carried out modeling of the approaches and compared the results with the current similar options. In Chapter 1 of the thesis, we consider polyharmonic signals with permanent parameters, and in Chapter 2, harmonic signals with changed amplitudes and phases. And for both signals, we devised a unified scheme, a unified approach to the assessment of their parameters. That is reduced to the fact that we don't only have initial signal, we also consider manifold delay signals, based on which we can synthesize certain linear regression model. And thus, it turns out that initial problem to assess the signal that is not linearly dependent on the parameter is reduced to the problem of assessment of linear regression parameters. And in Chapter 1, we consider polyharmonic signal that contains n of harmonics, and the upper and lower border of the level are known. And we assess all the parameters of the signal, thus that the error would be reduced to zero. The approach has a cascade structure, so on the first stage, we synthesize the assessments for frequencies, and based on them, we restore the values of phase amplitudes. And in order to assess the frequencies, initially we consider the initial signal and two delayed signals, and we prove that they satisfy this requirement 3 that can be rewritten as a linear regression. And vector of unknown parameters is dependent on cosine of frequencies to the delayed time according to the Vieta formula. And then we use the dynamic extension and mixing method for regressor, and it allowed us to take this regression model into the consideration of the system of n regression models of the first degree. And thus we can assess the parameters of these independent equations separately. And then to the regression model of the first order, we applied the gradient descent method, and the assessments guaranteed potential convergence of error to zero. Based on these assessments, we restored or synthesized the values for the finite time, and this time can be assessed as a sum of all these delays that we see in the method. And then, out of the assessments that we had of this regression model, we restored the values of frequencies. And to that, in the work, we considered two approaches. The first one is based on reverse trigonometric function, and the second one is based on the dynamic model. And at that, just the first one has the convergence for finite time. You see it in red on the graph. And the blue is the use of the method of dynamic model. It has this potential character of convergence. And when we have certain noise in the measurement, we can still improve this dynamic sum of the values using this dynamic model. However, later on, we're going to use the first approach for the finite time. And out of the assessments that we made, out of these estimates, they can be taken to the initial equation for the signal, to this 9 equation, and it can be rewritten as a linear regression model with dimensionality to n, and the vector of unknown parameters is dependent on the phase amplitude here. And then we apply the method of dynamic expansion and mixing of regress and modified gradient method that allows us to obtain the estimations for the finite time for phase amplitudes. And on the slide, you see the results of modeling for the approach considered, and we compare it with two algorithms, 2 and 3. First is based on adaptive observer, and the second one uses filtration. We see that the approach has the convergence for finite time, and it remains only also in the presence of some high-frequency perturbation. And the assessment will converge into some true value plot. Then the second chapter considers harmonic signals in which the amplitude and phase are considered changeable, so they are not permanent. And on the slide in blue, you see those signals that are seen as measurable or known, and the red ones are those parameters that are unknown. And for all these signals, we can use the applied approach. We measure the signal and the delayed signal. And based on them, we synthesize the linear regression model, and later on, we apply the dynamic mixing and expansion method, and then we assess the frequency in this chapter, second chapter. And also, in the condition that both signal and the amplitude are considered known, there is one simple solution of division, and thus we define the frequency. You see this graph in blue, and we see that the assessment has some outbreaks that correspond to the time periods when the amplitude goes through zero. And the overall target setting for Chapter 2 is that we need to establish the assessment of frequency that would guarantee exponential convergence of assessment error to zero. And at that, we synthesize linear regression model, as I've mentioned. And in order to prove exponential convergence, there is a prerequisite to have this persistent excitation for regressor, for example. But that's not true for all the systems, and for such signals we offer we devised methods that would still allow to obtain the exponential convergence for assessment. The first method is the method with memory, and based on a regression model of the first order, we synthesize a new model, and its regressor accumulates the values of the initial regress and its root, and thus we get it that the new synthesized regressor will meet these conditions of persistent excitation. And the second approach is a recursive approach, because in every period of time there is a comparison of the current value of regressor and regressant and some of the inscribed ones, and we choose the maximum for module. And even if the signal is damping and it has some small value in module, we'll just take some previously inscribed values. And for every of these methods, we've proven that if the initial regress is a continuous function and it may equal 0, then synthesized with such two modes, the regression model will satisfy this condition of persistent excitation. Then on the slide you see the results of modeling of the methods proposed in order to assess the frequency of harmonic signal with exponentially damping amplitude. And at that we considered the results using this method in work 4, and it was demonstrated that in the presence of high frequency perturbation, this approach, fourth approach, gives us a drift in estimation. And the approach that we offer in our thesis does not have this problem. That chapter is dedicated to the possible applications of assessment methods, and the first goal is to assess the rotation speed of the rotor with permanent magnet synchronous motor. And it is believed that the voltage is measured, and this gives us some additional admission. And thus we reduce this problem to the assessment of frequency of harmonic signal within some known amplitudes and phases, and that these amplitudes and phases are not permanent. So that's the case from the second chapter. And the second example, for marine vessel with synthesized control regime that was tuned to certain central frequency of perturbations of the system, and thus it provided economic control mode for the vessel. I won't dwell upon this in details, but if there are questions, we may discuss it. And finally, I would like to draw conclusions and to voice the results that we've managed to achieve. First of all, we offered a new method for the assessment of amplitudes, frequencies, and phases of polyharmonic signal for finite time. Then we offered new methods for assessment of frequencies with sine signals with amplitude and phase that are changed in time, that provide exponential convergence of error to 0. And we also devised two methods, relaxation method that allows us to get the assessment for unknown parameters in the regression model, even if we don't meet the condition of persistent excitation. The results were delivered on international conferences and published in 10 articles. Thank you so much. If there are any questions, I'll be glad to take them. So, distinguished colleagues, are there any questions before we shift to our report? Just the members of the board. And during the general discussion, we may listen to everyone who's present at the session. I don't see anyone willing to ask questions right now. Okay, then. So we continue. Just for our information, I would like to say that due to this change in code of this specialization, I would like to say that all the reports were submitted before these amendments were introduced to this specialization code. So I would like to ask the members of the board if they agree to recognize these reviews and reports as the ones that correspond to specialization 231. But I believe that's you know, something that we have no doubts about. We agree with that. Okay, thank you. There's no other solution here, I believe. Okay. Now I would like to ask the members of the board to read just some comments from their reports, because all the reports were published on the St. Petersburg State University website. So you can give just the basic points, the questions, or maybe some remarks to the candidate for the degree. Do you agree with that? Oleg? No. Okay. And our colleague who is working remotely has no objections as well. Okay, thank you. So now let's start reading our reports. Let's go according to the order that I've already voiced. First, we're going to listen to Alexei Zhabko, then Nikolai Kuznetsov, then Alex Stepanov, then Denis Yefimov, and then I'll be the last one to read my report. That's it. That's it. Let's read out our reports. Alexei, please, you have the floor. Yes, thank you, Nikolai. All as that we decided already, the relevance was already mentioned by our candidate for the degree, and therefore I can just make a conclusion here on the relevance, that the relevance of the research is not questioned. It is defined by the development of new identification methods that give us this characteristic of global convergence. And the following results can be considered for this thesis. So the theoretical results as follows. She synthesized the adaptive algorithm for the assessment of frequency of non-moved polyharmonic signal with permanent parameters based on joint processing of signal in several delayed periods of time. And also exponential convergence for error is considered. And also she defined a constructive algorithm for the assessment of frequencies of polyharmonic signal that guarantees convergence of assessment of parameters to true values or during finite time. And based on these assessments, she offered an identification algorithm for all the harmonics of the measured signal. I believe I can add a bit here. This method, I was initially surprised that she used this method, but then it became clear that it's quite applicable here. And the second point is that if we take it as an initial report stage, so we got final values, and then we can use linear approximation methods quite comfortably in order to assess the noise and some robust characteristics. So that's a good point. It's not always the case, but still here, with this problem, we had it. Then, she synthesized simplified adaptive algorithms for frequency identification for non-moved harmonic signal with an amplitude change in time, then moved a signal with changing amplitude, then harmonic signal with changed amplitudes and phase, then moved harmonic signal with exponentially damping amplitude. Fourth, she proven the exponential convergence of errors to zero for signals with non-stationary amplitude. And fifth, she devised two relaxation methods that provide for the convergence of assessment error to zero when the condition of persistent excitation is not met. And the following solutions are offered. She synthesized the observer of the permanent angular speed for the rotor, PMSM rotor, and then she synthesized multi-target control system when in case of polyharmonic external excitation sources. And here I agree with our candidate for the degree when she formulated the results. Then substantiation level of the defense provisions. First of all, the validity is achieved by a systemic approach to the description, then the use of fundamental provisions of theory of identification and automatic regulation, and also by the testing of the basic results at conferences and congresses. She published 10 works on the topic, and 9 publications are made in journals of that are indexed in Web of Science and Scopus. As for the structure of the thesis, so I describe it here. I believe described it all in details, and she was quite accurate about the description. And every chapter has these results of modeling that prove the validity of methods, and this approach is compared with existing similar approaches on different values of fine-tuned parameters of the measured signals. And I believe I'll make some comments about the misprints. For example, in the introduction, there's no description in the structure of the thesis, and she separately mentions 3.2 section. And in this chapter with the introduction of delay, it does not describe the methods correctly. It would be more correct to either omit these words or maybe to rephrase them somehow. Third point. Chapter 1 of the thesis is dedicated to assessments of all parameters of frequencies of phase amplitudes in the polyharmonic perturbation, and in 1.8.2 section, when there is comparative analysis, these results of comparisons are given just for frequencies, and the assessments of amplitudes and phases according to the algorithm, they are based on the assessments of frequencies, so they are considered through the cascade approach. And numerical modeling results are interesting in a case of noise and in case of change of parameters, and also the conclusion. The conclusion is as follows. So, the thesis meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University. So the thesis as a scientific monography of the candidate for the degree, Anastasiia Vediakova, titled Real-Time Estimation Methods of Parameters for Harmonic Signals with delay introduction, meets the requirements of the order as of September 1st, 2016, on the procedure of granting academic degrees at St. Petersburg State University, and Ms. Vediakova deserves the academic degree of the candidate of sciences in physics and mathematics in specialization 231, system analysis, control, and information processing, physics and mathematics. And Article 11 of the above-mentioned order is not violated. And my signature here, Doctor of Science in Physics and Mathematics, Head of the Department of Control Theory of St. Petersburg State University, Alexei Zhabko. Thank you, Alexei. Anastasia, you can answer the comments. Thank you so much, Alexei Petrovich, for your remarks. Yes, indeed. This content is not given separately in the introduction. It's given in the start of every chapter. Maybe for the reader it would be more convenient to have it somewhere in the beginning of the work. And as for the delay, here we consider the initial signal and the delayed signals. And that's the key idea in the proposed approach. Therefore, jointly with my thesis supervisor, we made a conclusion to introduce it into the title of the thesis, though certainly we may have some more accurate wording for that. And as for experiments in chapter 1, indeed, The amplitudes and phases are described in the previous article, and they were not included later on because for the proposed approach they are not different for the assessments of from the assessments of frequencies because they happen in finite time. Thank you. Alexei, are you satisfied with the answers? Yes, yes, I am. Okay. Nikolai, please, you have the floor. Thank you so much. I won't read out the entire review because it was already published and you can read it in detail. But still, I would like to mention the relevance of this work, and I would like to add that I'm just back from the Lapranta Technical University, where we opened a joint program where St. Petersburg and Polytech will, St. Petersburg State University and Polytech will participate, and there were labs that develop rotors, such engines on permanent magnets. And 2 days ago, we discussed that our Finnish colleagues are very interested to cooperate in this field that you offer, because they are now quite interested to work with identification and control devices. So I invite you to participate in this work. And I believe this work is written at a very good mathematical level. It's well structured, it's convenient. It's convenient to read it, and all the results are tested in prestigious publications, and all the requirements of the order on the procedure of granting academic degrees are met. And as remarks, I would like to mention the following ones. In assumption 6 and 8, there are limitations on the amplitude, but it's unclear what are the conditions for the signal. What do you need in order to have this correspondence with the conditions on regressors? And also, in the report, I have two, cosmetic comments on the use of graphs and variables. But still, these comments do not compromise the overall very high value of the work that gives us the results that resolve the current problems. Thank you. Thank you. Thank you, Nikolai. You can answer, Anastasiia. Yes, thank you so much for your report, Nikolai Vladimirovich. Indeed, in Chapter 2, when we consider harmonic signals with variable amplitude, it was hard to define certain conditions for the amplitude in order for the signal to satisfy this condition of permanent excitation. But if it's not the case and the signal does not satisfy this condition, we can use the applied relaxation methods to it, which, based on the signal, will form the new regression model, and then it will satisfy the conditions. Thank you. Thank you. I'm satisfied with the answer. Okay. Thank you. Oleg, you have the floor. Thank you. This work is certainly relevant because it is dedicated to the solution of the problems, current problems, that are not described directly in the passport of specialization, with observers and filters, in the development of different technical systems, and in different other systems. And in this regard, this work is dedicated to the synthesis of the observer, and I believe there's no exact definition here, but if we're talking about the assessment from the point of view of determinant approach, and we have it here, then the device is considered as an observer, and this problem is quite relevant because those parameters and those signals that are used for the assessment, they give us a non-linear problem of estimation, and there's no unified solution for such problems. And the process of invention of different successful algorithms is not finite at all. So this work is quite relevant. I won't dwell upon the results. They were reported already and reported quite well. And other colleagues have already mentioned that, so I'll dwell upon the comments that I had. And they can be seen as recommendations, I believe. The approach that the author used, the development of determinant approach of regress extension and mixing method. A lot of works were published on the topic, and here this problem setting is the basis, the one that provides for the fact that signals used for assessments do not contain measurement errors, and it was mentioned by the first colleague. And then in some conditions we add up noise to some points, and then we analyze the estimation error. Maybe it would be better to consider the problem that initially considers the use of noise, and thus you can introduce criteria and resolve the problem. Unfortunately, in the work there are no references to such a process, to such approaches, and they are not discussed in the work. And maybe it would be expedient to bear that in mind in order to develop your theory later on using such a problem setting. And second remark is dealing with the fact that basically in the work there's no introduced criterion for the use of problem resolution. Here I'm talking about the provision of some or other convergence or with final time. Certainly we can resolve the problem like that, but if we would have a criterion, it would be simpler to assess the quality of the proposed observers. Then some insignificant remarks about the terminology. Maybe that's this condition of persistent excitation, that's quite a term, you know, a bit ambiguous. And I believe here you are talking about the conditions of observations that were long introduced in the theory of observation. Here we are talking about the opportunity to assess the signal, and it's better when we have some prehistory of observation, how this persistent excitation condition is connected with the conditions of observation. As for adaptive algorithm, the question is as follows. How do you adapt to what are you adapting to what parameters and conditions do you use your adaptation? And finally, that's the consequence of the fact that there's one popular approach in the department, and the efficiency of the use of assessment devices within the framework of stochastic approach provides for certain error, and it's actively used in practice. And in Russia was always famous for the use of this approach in Zhukovsky Academy as well. And certainly it would be nice to see these developments of stochastic approach. And we're talking about accidental noise, some accidental process. What kind of process is that? It's not clear, and in applied maths department, I believe this terminology should be more exact. So these are my remarks, but overall the work is assessed as quite positively, and all the words are written here in my review. I believe there's no need to repeat them. Okay, Anastasiia, you can answer. Thank you so much, Oleg Andreevich, for your advice and report. For the fact that I did not introduce analytical noise and did not assess the influence on the obtained estimations. Yes, indeed, we consider the ideal problem, and in the presence of such results, it would be stronger result that would have a more applied value, I believe. And then about the observation and linear regression, I made a special slide for that shows that the condition of persistent excitation is applicable to linear regression models. Linear regression models. Yes, to the regressor. And for the case when we have linear non-stationary system, this condition of observation, full observation, we need the columns of the matrix, where phi is fundamental matrix of solution. They should be linearly independent. But if we form the same linear model with stationary parameters, that will give us a linear regression model, then the observation criterion will be the linear independence of columns of the regressor. And that is not a sufficient condition for persistent excitation. For example, if in the columns we would have some exponential damping signals with different values, certainly they will be linearly independent, but the conditions will not be met, the conditions of persistent excitation. Then, as for quality functional, that was not introduced. In fact, we don't have them, and we guarantee certain type of convergence, and it is broadly applied in works associated with control theory. For example, further I'll plan to use these assessments in the contour of reverse feedback. I need to guarantee some type of convergence so that the regulator, based on these assessments, would be stable, would have this stable closed loop. And as for some accidental processes and adaptive observer, indeed, I agree with that. I should have specified it and introduced those notions in more detail with full description. Yes, thank you. Still, I have a question on the adaptation. What kind of adaptation is that? Yes, thank you. That's, well, this word adaptation, maybe it's not quite a good choice. We adapt to the change of parameters, but that's quite clear because we are providing an estimation for the observer of these parameters. Well, I would dispute that. As for observation, you reduced everything to the matrices, but I offer you to think about this problem. You assess permanent vectors according to scalar estimations. Y from T equals H from T multiplied by a vector, and that's a line. There are no conditions of observations that observation that you're talking about, but there is a notion of observation. And what are the conditions that the matrix should meet H from T, so that I would assess this vector, so that we would have this observation condition. And here you'll see this persistent excitation. So there are some points to think about here. Okay, thank you. Okay, we can continue our discussion during the general discussion. And Andrea, I believe you could give us more details about that. And now I would like to give the floor to Denis. Valentinus, Denis, do you hear me? Yes? Your view was given in the English language, I believe. I believe you can give it in Russian. Yes, certainly I will give it in Russian. Yes, I won't read it out. I'll just give the general information. Okay, yes, Denis, thank you. And as I'm the last speaker, the majority of remarks were already voiced, and I can just join in and say that I really believe that this topic is quite relevant, and there are the problems of assessment of parameters of the canonic signals that people are trying to resolve. There are a lot of approaches, and you've demonstrated it in the thesis. and in the presentation. And it seems to me that it's very important and interesting to get an improvement of the existing theory when it is already developed, and you managed to do it quite successfully. You managed to resolve one important goal that is not just abstract, but you also improved the qualitative characteristics, and you managed to show the convergence for finite time. But on the other hand, as colleagues mentioned, unfortunately you did not consider the impact of noise. And here I can just join in this question, because it seems to me that that's a bit of a mission, because if you consider this problem without noise, there are different conditions, and the solution can be different from the one that you offer for noise. And these algorithms are something that we don't need if we don't have a noise. And you consider the systems that are searching for conditions. And this condition of persistent excitation, we need it only in case when we have noise. If there is no noise, we have different conditions for observation. So that's a question, and I don't know, a comment to what Alex said. And I have some other technical remarks in my report. I won't read them out because, well, they are just auxiliary. I just want to ask one question. You got a very nice result on the relaxation, considering persistent excitation, that we can use some technical tricks to obtain linear regression once again, where this condition is met. Could you please tell me, don't you think that you violate some conditions of technical implementation, because they previously tried to connect this observation with the same condition of persistent excitation, and initially the goal was not observed? So how do you manage to use some additional algorithms to make it observed? And in conclusion, certainly I would like to join in and say that regardless of some technical omissions, still Anastasiia deserves this degree, academic degree of candidate of sciences and physics and mathematics in this specialization. Thank you. Thank you, Evgeny. Anastasiia, please, you can answer. Yes, thank you so much, Denis. Indeed, this question was not considered in the thesis, and I believe it requires further development, and right now I can't answer the comment, because considering the fact that, well, or rather I put it this way, if the offered relaxation methods are applied to linear regression model of the first order, if initially it was of a higher order, we use the method of dynamic expansion and mixing, and we can assess them separately. And if I say, if I'm talking about regression model of the first order, and the condition of its observation, there is regressor, there, some kind of scalar function like regressant, and that's a single parameter. So the condition of its observation, so that it won't be zero, and that's what we need in our assumption, that we have just one moment of time when it's not zero. And there's this contradiction for noise and the absence of noise. For example, if there's no noise, we can have any single first moment of time when regressor is not equal to zero, and thus we get an estimation. And all these conditions of persistent excitation, we need them when there is noise. You just can't divide, but when you divide it, noise can be quite bad. and take into account some stochastic characteristics of noise and determinant characteristics of noise. Using imperative procedure, we get an improved assessment. And these are the questions that are interdependent. Thank you for the answer. Thank you. Thank you, colleagues. As Denis said, his report was the last one. Let's believe that my report will be a finalizing one. So the report of the chairman. My goal is quite simple, because the reports were already mentioned, and these reports have already dwelled upon the positive aspects as well as some negative ones. Certainly, when I analyzed the thesis, I described similar advantages. And I would like to dwell upon the scientific novelty of the results that the author managed to obtain. First, she devised a new algorithm of identification of parameters of non-moved polyharmonic signal for finite time. Second, she devised the new algorithm for the assessment of frequencies of harmonic signals with changed parameters. Third, the author offered two relaxation methods applicable to regression models where the regressor does not meet the persistent excitation conditions. And the simplified scheme for angular speed assessment is also offered for the Rotov synchronous motor. And the fifth point. For the first time, the author considered the issue of applicability of the approach to multi-target vessels that are influenced by polyharmonic perturbations, and also the validity is considered, and I considered all the chapters, though it's not mandatory, but still I decided that I'll do it in my report. So I considered all the achievements of every chapter. I also mentioned the applied examples that can be implemented based on theoretical and numerical results of the study. And as any work, it has certain drawbacks, and I mentioned 4 of them. The first one, in every chapter we have the results of numerical modeling of the assessment methods, and it would be nice to see the flow chart with fragments of initial code in MATLAB. Then all the mathematical results have mathematical proof, but along with that they are defined as assumptions. In order to define them, maybe you should have used theorems, lemmas, assumptions, and so on. Then signal 2.4 has the mentioned frequency, but on page 220, the frequency is 50. And also, what I write here, that you use concise language for the results, but there are still some syntax mistakes. But overall, as other members of the board, I believe that this thesis complies with the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University, and Ms. Vediakova deserves the academic degree of the candidate of sciences in physics and mathematics, in specialization, system analysis, control and information processing, physics and mathematics. And Article 11 of the above-mentioned order is not violated. So that's it. Dear colleagues, Anastasiia, please, you can answer. Thank you, Nikolai Vasilievich, for your comments. Indeed, regardless of how much I read the text, how many times I read the text, still there are certain drawbacks, and in the text I should have this 50 reading per second, and the modeling would be quite useful for the scientists that will apply or compare the algorithms with the one that's offered. So I'll take that into account. Thank you. Okay, Anastasiia, thank you. I'm satisfied with your answer. Distinguished colleagues, distinguished members of the board. So we all got answers to our comments, but maybe someone has some additional questions. So are you satisfied with the answers to the questions of your colleagues? Yes, Nikolai says yes. Oleg? Yes, okay. Now I would like to ask the colleagues who are here with us, does anyone want to ask a question? Yes, you can raise your hand. No one wrote the name in the list, but I see there are no one who's willing to ask a question. Okay. Natalia, do we have any comments online? No, right now not. Okay. Okay, currently we have none. Let's think that we have none. Well, unfortunately, we can't listen to the thesis supervisor, but we are his colleagues. And Evgeny was the founder of the department. I worked for many years, and certainly we know that he made a contribution to this work, that he guided this work of Anastasiia, he corrected, he helped her. So certainly he won't let her go for the defense if he was dissatisfied, because he was quite a good scientist and thesis supervisor as well. And if there are no other questions, and no one is willing to take the floor, I believe we can still have open discussion, though we already had it during this questions and answers session, and Oleg made some comments, Denise made some comments, so I believe that we were satisfied, and this was quite interesting to listen to this discussion. And I really liked the points of Oleg Andreevich in terminology. Mathematicians are sometimes negligent about the terminology, and they may introduce certain unclear terms, though they are quite familiar in physics and in technology. And I believe Anastasiia in the future and members of the department will bear this in mind. And I believe we can draw conclusions before the finalizing poll. And I would like to ask the members of the board and our candidate for the degree if there are any comments or questions about the procedure of the of our board session, maybe the ones that are associated with remote access. So, Denise, do you have any comments about that? None? Okay, we heard you quite well and saw you quite well, so thank you so much for being with us. Dear colleagues, any comments? No? None? No comments about that. So next point. I would like to ask if the members of the board want to discuss this situation in a separately, or maybe we can have open balloting. I believe we have some. So I believe we share the views about this thesis, so there's no need to hold a separate discussion. Well, I believe everything is clear, so there's no need to ask colleagues to leave, and we can vote straight away. Nikolai, what about you? Well, I believe the same. Okay. So I ask you to vote. Who votes for the award of the academic degree in specialization, system analysis, control, and information processing to Anastasiia Vediakova? Please raise your hands. Okay. Okay, yes. We see everything. Yes, we saw your hand as well. So thank you, colleagues. Now, according to the procedure, counting your votes, I would like to say the following thing. Distinguished colleagues and guests, I would like to announce that out of the 5 members of the board, 5 people voted for the award of the academic degree. So no one abstained from the vote and no one voted against. So, therefore, we award the academic degree of candidate of sciences and physics and mathematics in specialization 231, system analysis, control, and information processing to Anastasiia Vediakova. Distinguished colleagues, once again, according to the procedure, I need to ask you the following question. If there are any comments or any questions about the procedure. I believe Natalia can answer this question. No comments about that. Okay, now we would like to give the floor to Anastasiia for the finalizing remarks. Thank you so much. I would like to thank the members of the board, because every of your reports really helped me a lot, and I believe they will help me in the future, because indeed I have some plans for future work, so thank you very much for that. I would like to thank the colleagues from my department who supported me and who helped me, and I would like to thank my family who supported me in everything, because without them it would not be possible. Thank you. Thank you, Anastasiia. And I would like also to thank Natalia Karpova for the excellent organization of this event, of this defense. Everything is organized quite well. Every time she is quite attentive. She always supports us, and so thank you so much, Natalia, about that. And Anastasiia, let's shake hands. And on behalf of the academic board, I would like to congratulate you with successful defense, and we wish you further success in your work. So, dear colleagues, we close our session.